You've probably seen a map of the night sky before. Neat constellations connected by dotted lines, printed in a textbook or projected on a planetarium dome. Clean. Understandable. Modern. But what if I told you that scattered across remote corners of the world, people who lived thousands of years before the invention of writing were carving those same patterns into stone, with an accuracy that would make a NASA engineer pause mid-calculation? We're not talking about crude stick figures or vague circles. We're talking about precise angular measurements, seasonal alignments, and celestial coordinates etched into boulders weighing several tons, positioned on hilltops and canyon floors where no one should have had the tools or the need to map the heavens with such obsessive detail. These aren't the famous megaliths you learned about in school. These are the forgotten ones, the sites that don't make it into the glossy coffee table books because the questions they raise are too uncomfortable, too unresolved, and too strange to fit neatly into our timelines of human progress. Over the next hour, you and I are going to walk through 6 extraordinary archaeological mysteries, each one centered on what researchers have started calling star chart stones, carved rock surfaces that appear to document astronomical knowledge far beyond what we thought ancient cultures possessed. We'll explore who made them, why they bothered, and what they might have been tracking in the night sky centuries before anyone was supposed to understand orbital mechanics. Some of these sites whisper of lost seafaring peoples who navigated by stars we can barely see today. Others hint at ritual calendars tied to events we can't quite reconstruct. A few carry legends of giants, curses, and visitors from distant lands who arrived under strange moons and left only these stones as proof of their passage. I'm not here to sell you a single explanation. I'm here to show you the evidence, lay out the competing theories, and let you wrestle with the same questions that keep archaeologists awake at night. Because here's the truth. For all our satellites and supercomputers, we still don't fully understand why people who lived in hide tents and cooked over open fires cared so deeply about charting the stars. So settle in, turn off your phone, and prepare to question everything you thought you knew about the ancient world. Because the stones we're about to examine don't lie. They just refuse to give up their secrets easily. Picture a narrow river valley in what is now northeastern Mongolia, where the Onan River winds through grasslands so vast they seem to swallow the horizon. It's a landscape of extremes, scorching summers, bone-cracking winters, and skies so clear on moonless nights that the Milky Way casts shadows on the ground. And it's here, on a series of low granite ridges overlooking the river, that herders in the 1970s stumbled upon something that still has no satisfactory explanation. The Kavtskite Plateau stones, a collection of 47 boulders, each between 2 and 4 meters across, covered with thousands of small circular depressions arranged in patterns that match, star for star, angle for angle, the constellations visible from that exact latitude during the Late Bronze Age, roughly 1200 to 900 BCE. When Mongolian archaeologist Bayar Sayhan Jamsaranjov first documented the site in 1983, he assumed the carvings were decorative, perhaps territorial markers left by nomadic clans. But then a visiting Russian astronomer named Yevgeny Kuzmin spent 3 nights at the plateau with a theodolite and a star chart. And what he found changed the conversation entirely. The depressions weren't random. They formed clusters corresponding to Ursa Major, Cassiopeia, Draco, and a dozen other northern circumpolar constellations, with angular separations accurate to within 2 degrees. Even more startling, several stones appeared to document the positions of planets, Jupiter, Saturn, and Mars, on specific dates that Kuzmin was able to calculate backward using modern ephemeris tables. One stone, now labeled Kavtskite 12, shows a grouping that matches a rare planetary conjunction visible on the night of September 14th, 1147 BCE, an alignment that wouldn't repeat for another 850 years. Who carved these stones, and why did they care about a single night sky configuration? The short answer is we don't know. The culture that occupied the Onan Valley during that period is called the slab grave culture, named for their distinctive stone-lined burial chambers. They were semi-nomadic pastoralists, herders of horses and cattle, and they left behind almost no written records, just graves, pottery shards, and these enigmatic stones. There's no evidence they built permanent observatories or maintained a priest class dedicated to astronomy. Yet the precision of the Kafskite carvings suggests exactly that kind of sustained, multi-generational observation project. Some researchers, including Kuzmin himself, have proposed that the stones were navigation aids, a kind of portable star map used by traders moving between the Mongolian steppe and the distant markets of northern China. But here's the problem. The stones weigh upward of 3 tons each. They're not portable. They're not even movable without a team of oxen and wooden rollers. If they were meant as navigation tools, why anchor them to a single plateau? Others have suggested the stones served a ritual function, that the slab grave people believed certain nights when planets aligned or when particular stars crossed the zenith, were cosmically significant, perhaps tied to births, deaths, or seasonal migrations. There's some support for this idea. Excavations around the stones have uncovered fire pits, animal bones, and fragments of bronze jewelry, suggesting that people gathered here, possibly for ceremonies. But again, why the obsessive accuracy? Why document a planetary conjunction that happened once in a millennium, unless you believed it would happen again, or unless you were trying to communicate something to future generations? Then there's the legend, the one the local herders still whisper about when the wind picks up at dusk. They call the plateau Chononi Kad, the stones of the star people. According to oral tradition passed down through countless generations, the stones weren't carved by human hands at all. They were left by giants, tall beings with pale skin and silver eyes, who descended from the sky in a time before horses, before fire, before the first winter. These giants, the stories say, could read the future in the movements of the stars, and they carved the patterns into stone as a warning, a message that something, some event, was coming, and that the people of the grasslands needed to be ready. Folklorists dismiss this as mythologized memory, perhaps a cultural echo of contact with a forgotten migration wave or an unusually tall ethnic group from the West. But the herders insist there's more to it. They point to the fact that several of the stones are aligned not just with the stars, but with distant mountain peaks and river bends, creating sightlines that extend for dozens of kilometers across the valley. One elder told Jamsranjav in a 1991 interview that his grandfather had seen sky fire above the plateau on certain nights, and that the stones grew warm to the touch when the stars were right. Atmospheric phenomena? Ball lightning? Or something stranger? We don't have answers. What we do have are the stones themselves, silent and unyielding, each one a testament to the fact that someone, at some point in the Deep Bronze Age, looked up at the night sky over the Onan River and decided to make a permanent record of what they saw. And that record, for reasons we still can't fully explain, required a level of astronomical knowledge that shouldn't have existed for another 1,000 years. Picture yourself standing on that plateau at dawn, frost clinging to the grass, the rising sun casting long shadows across the circular depressions in the stone. You trace your finger along the pattern, following the invisible line from one carved star to the next, and you realize that you're touching the same constellations that someone else touched 30 centuries ago. You're part of a conversation that spans the ages, a conversation written in stone and starlight, and the question that hangs in the cold morning air is simple and profound. What were they trying to tell us? We still don't know. Now let's travel halfway around the world to the wind-scoured coast of what is now southern Peru, where the Pacific crashes against cliffs of black volcanic rock and the Atacama Desert begins its slow march inland. Here, in a series of narrow canyons cutting through the coastal range, archaeologists in 2003 uncovered something that defied every assumption about pre-Columbian astronomy: the Paracas Horizon Tablets, a collection of over 200 flat stone slabs, each roughly the size of a dinner plate, engraved with intricate dot and line patterns that recent analysis has confirmed are star charts, accurate, detailed maps of the southern celestial hemisphere as it appeared between 600 and 300 BCE. The Paracas culture, known primarily for their elaborate textile work and elongated skull burials, occupied this stretch of coastline for nearly a millennium. They were fishermen, weavers, and traders, part of a network that extended up and down the Andes. They built no cities, no pyramids, no grand monuments, but they left behind these tablets, tucked into small caves and rock shelters overlooking the sea, each one a window into a night sky that most of us have never seen. Dr. Elena Ruiz, the Peruvian archaeologist who led the initial excavation, describes her first encounter with the tablets as a moment of pure disorientation. She and her team had been investigating a Paracas burial site when they noticed a series of shallow alcoves carved into the canyon wall about 10 meters above the cave floor. Inside one alcove, wrapped in decayed cotton fabric, were 16 stone tablets stacked like dinner plates. When Ruiz carefully cleaned the surface of the first tablet under laboratory conditions back in Lima, she saw what she initially thought was abstract decoration: a field of small drilled holes connected by faint incised lines. But when she photographed the pattern and overlaid it onto a modern star chart of the southern sky, she froze. The pattern wasn't abstract, it was Centaurus, the constellation that dominates the southern horizon, complete with Alpha and Beta Centauri in their correct relative positions. Over the next 6 months, Ruiz and her team analyzed all 200 tablets recovered from the site, and the results were staggering. The tablets documented not just individual constellations, but seasonal star positions, lunar phases, and even what appeared to be tracking of Venus as it moved through its synodic cycle. Several tablets showed the same constellation viewed from slightly different angles, suggesting that the Paracas observers understood parallax, the apparent shift in position of an object when viewed from different locations, and were using it to estimate celestial distances or to synchronize observations from multiple sites along the coast. The precision is unnerving. One tablet, cataloged as PHT-47, shows the constellation we call Crux, the Southern Cross, with an additional faint cluster of dots positioned exactly where the Coalsack Nebula, a dark cloud of interstellar dust, blocks out the background stars. The Coalsack is visible to the naked eye, but only barely, and only from latitudes south of the equator. That the Paracas observers noticed it, recorded it, and understood it as a distinct feature of the sky is remarkable. That they did so without telescopes, without precision instruments, and without a written mathematical system for recording angles and distances is almost incomprehensible. So what were they doing with this information? The prevailing theory, championed by Ruiz and her colleagues, is that the tablets were navigational aids tied to maritime trade. The Paracas people were accomplished seafarers. Archaeological evidence shows they traded with cultures as far north as present-day Ecuador and as far south as the Chilean coast, a span of over 3,000 kilometers. Navigating those waters, especially at night or during the frequent coastal fogs, would have required reliable celestial reference points. The tablets, according to this interpretation, were a kind of portable astronomy reference, a way for sailors to orient themselves when landmarks were invisible. But there's a wrinkle. If the tablets were practical tools, why make over 200 of them? Why hide them in alcoves far from the shore? And why include features like the Coalsack Nebula, which has no obvious navigational utility? Some researchers, including Dr. Marcus Holt of the University of Queensland have suggested an alternative, that the tablets were religious objects, part of a cosmological belief system in which the stars represented ancestors, gods, or spiritual waypoints for the dead. Paraka's burial practices, after all, were complex and ritualized. The famous elongated skulls, achieved through cradle boarding in infancy, suggest a culture deeply invested in altering and marking the human body for symbolic purposes. Perhaps the tablets were guides for the soul's journey after death, maps to help the deceased navigate the night sky on their way to an afterlife realm associated with particular stars or constellations. There's indirect support for this idea. Several tablets were found in direct association with burials, placed either on the chest of the deceased or wrapped in the same textile bundles that covered the body. Chemical analysis of residue on the tablets shows traces of red ochre and plant resins, substances commonly used in Paraka's funerary rituals. And then there are the stories, the ones that don't make it into peer-reviewed journals, but that the local Quechua-speaking communities along the coast have preserved in their oral traditions. They speak of the Wari Runa, the Star People, ancestral beings who lived along the cliffs before the Parakas, before the Inca, before memory itself. According to these stories, the Wari Runa could speak to the stars, and the stars spoke back, teaching them the patterns of the ocean, the cycles of the fish, the secret paths through the desert. When the Wari Runa finally departed, some versions say they sailed west into the ocean, others that they climbed into the sky on ropes of woven light. They left behind the stone tablets as proof of their covenant with the heavens. Folklore, certainly. But folklore with a peculiar specificity. One elder, interviewed by Ruiz's team in 2005, described the tablets as the songs of the sky people, written in stone, so the songs wouldn't be forgotten when the singers were gone. And when you hold one of these tablets in your hands, I've been fortunate enough to examine several at the National Museum in Lima, you feel the weight of that metaphor. Each drilled hole is perfectly round, no more than 3 millimeters in diameter, executed with a precision that would have required a fine stone drill and a steady hand. The lines connecting the dots are hair-thin, almost invisible in certain light, but when you tilt the tablet and let the light rake across the surface, they leap into visibility, a network of connections waiting to be read. Imagine standing on those cliffs at midnight, the ocean wind in your face, salt spray dampening your skin. You hold a tablet in your hands, and you look up at the sky, and for just a moment, the pattern in the stone and the pattern in the heavens align perfectly, and you're no longer standing in the present. You're standing in the same moment as the person who carved this tablet 25 centuries ago. You're seeing what they saw, wondering what they wondered, and asking the same question that echoes across the empty canyons. What did the stars tell them that they felt compelled to write in stone? We still don't know. Cross the Atlantic now to the windswept interior of what is modern-day Chad, in the heart of the Sahara where sand and stone stretch in every direction under a sun so fierce it turns the horizon into a shimmering mirage. This is the Anedi Plateau, a region of sandstone towers, hidden wadis, and rock art so ancient it predates the pyramids by millennia. And tucked into a canyon system that has no name on any official map, accessible only by a bone-rattling 2-day drive from the nearest settlement, lies a site that has been known to Tuareg nomads for generations, but wasn't documented by Western archaeologists until 2011. The Tafadet Circle Stones, a grouping of 31 large sandstone blocks arranged in a near-perfect ring 38 meters in diameter, each block carved with clusters of small cupules, shallow, cup-shaped depressions that form patterns matching the positions of stars in the equatorial sky as they appeared approximately 40,500 years ago, during the African humid period when the Sahara was a patchwork of grasslands, lakes, and river systems. Dr. Abubakar Musa, a Chadian archaeologist working with the French National Center for Scientific Research, first visited the site in November 2011 after a Tuareg guide named Idris Ag Mohammed mentioned old stones with holes in a canyon 2 days' travel from the Entity Massif. Musa expected another rock art site. The plateau is famous for its Neolithic petroglyphs of cattle, giraffes, and human figures. But what he found was something different entirely. The stones, each weighing between 1 and 2 tons, were positioned upright in the sand, forming a ring that was clearly intentional, clearly designed. And when Musa began photographing the cupule patterns on each stone, he noticed something that made his hands shake. The patterns weren't random or decorative. They were constellations: Orion, Taurus, the Pleiades, rendered with the kind of attention to angular spacing and relative brightness that suggested systematic observation over many years. A team of French astronomers, led by Dr. Sophie Lefebvre of the Observatoire de Paris, spent 3 weeks at the site in 2013 conducting a full survey. They used laser scanning to create 3-dimensional models of each stone, then compared the cupule patterns to star charts reconstructed for various historical epochs using precession models. The results were unambiguous. The stones depicted the night sky as it would have appeared from that latitude, roughly 17 degrees north, around 2500 BCE, at the height of the African humid period when the Sahara was greening and human populations were expanding into regions that would later become impassable desert. Several stones showed asterisms, recognizable star patterns, that no longer align with their modern positions due to the slow wobble of Earth's axis, a phenomenon called precession. One stone, designated TC19, showed a cluster of 7 bright cupules arranged in a tight grouping that Lefebvre identified as the Pleiades, positioned exactly as they would have appeared at dawn on the vernal equinox in 2480 BCE. The precision is breathtaking, but the mystery deepens when you ask the obvious question: who built this and why? The Sahara in 2500 BCE was not the barren wasteland it is today. It was a living landscape populated by pastoralists who herded cattle, goats, and sheep across seasonal grasslands, who fished in rivers and lakes that have since vanished beneath the sand. Archaeological surveys of the Eneti Plateau have uncovered scattered campsites, pottery, grinding stones, and the remains of livestock pens. But there's no evidence of a centralized society, no cities or temples, no ruling elite with the resources to organize a monumental construction project. The Tafadet circle stones suggest a level of social complexity and astronomical knowledge that doesn't fit the narrative of small mobile bands of herders moving with the rains. Musa's hypothesis, published in a 2015 paper, is that the site was a regional gathering place, a kind of desert agora where different groups came together during specific times of the year, perhaps tied to the solstices or equinoxes, for trade, ritual, and social bonding. The star charts, in this interpretation, served as a communal calendar, a way for groups scattered across hundreds of kilometers to synchronize their movements and ensure they arrived at Tafadet at the right time. The fact that the stones depict the equinoctial sky supports this idea. Equinoxes are natural markers, moments when day and night are of equal length, easily observable without instruments. If you're trying to coordinate the movements of multiple nomadic groups across a vast landscape, telling them to meet when the Pleiades rise at dawn is a simple, reliable system, but not everyone agrees. Dr. Lefebvre and several of her colleagues believe the site had a deeper, more existential purpose. They point to the fact that the circle is oriented almost perfectly north-south, with the largest stone, a massive block nearly 4 meters tall, positioned at the northern edge. When you stand at the center of the circle on the night of the summer solstice and look north over the top of that stone, your line of sight aligns with Polaris, the North Star, to within half a degree. This, Lefebvre argues, is no accident. The builders of Tafode weren't just tracking seasonal events, they were marking the cosmic axis, the point around which the entire night sky appears to rotate. In many ancient cultures, the North Star was seen as the center of the universe, the nail that held the heavens in place. To build a monument aligned with that star suggests a sophisticated cosmological worldview, a belief system in which the movements of the sky and the movements of human society were intimately, inextricably linked. And then there are the Tuareg legends, collected by French ethnographers in the early 20th century, and largely ignored by mainstream archaeology, until Musa began asking questions. The Tuareg call the site Tafodet Ajir, the Circle of the Sky Giants. According to their oral tradition, the stones were raised not by humans, but by the Kel Esuf, a race of spirit beings who lived in the desert before the coming of the Arabs, before the spread of Islam, in a time when the land was green and the rivers flowed year-round. The Kel Esuf were said to be enormously tall, with skin like polished bronze and eyes that glowed like embers. They could see in the dark, navigate by the stars, and speak a language that sounded like wind over sand. They built the circle, the stories say, to mark the place where the sky touched the earth. And on certain nights when particular stars crossed the zenith, the barrier between the worlds grew thin, and the living could speak with the dead, and the future could be glimpsed in the patterns of light overhead. Folklore, of course, but folklore that contains odd fragments of astronomical knowledge. One Tuareg elder, interviewed by Musa in 2012, described the Pleiades as the seven sisters who guide the lost, and said that when the sisters appeared at dawn, the way would open. He didn't know the term equinox, but he was describing the same phenomenon that Lefebvre identified in the stone carvings, the heliacal rising of the Pleiades at the vernal equinox, a celestial event that has been significant to cultures around the world for thousands of years. Stand at the center of the Tafodet circle on a moonless night, and the stars press down on you with an intensity that's almost physical. The Milky Way arches overhead like a river of light, and the silence is so complete you can hear your own heartbeat. Look at the stones around you, each one a silent witness to a night sky that no longer exists, and you realize that you're standing in the footprints of people who looked up at the same stars and asked the same questions we're still asking. Where do we come from? Where are we going? And what do the patterns overhead tell us about our place in the vastness of creation? We still don't know. Let's shift our gaze eastward now, to the dense jungles of what is today northern Cambodia, where the Mekong River spreads into a labyrinth of channels, oxbow lakes, and flooded forests. This is Preah Vihear Province, a landscape of limestone karsts rising abruptly from the canopy, their flanks covered in thick vegetation that conceals centuries of history. And carved into the walls of a series of caves on one such karst, accessible only by a precarious climb up a 70-degree rock face, are the Ki Rith cave panels, 42 carved stone surfaces depicting what researchers now believe are star maps, ritual calendars, and astronomical diagrams created by an unknown culture between 800 and 400 BCE, long before the rise of Angkor and the Khmer Empire. The panels were first reported in 1998 by a French spelunker named Olivier Granier, who was exploring the karst system with a local guide. Granier photographed the carvings but didn't immediately recognize their significance. He assumed they were Hindu or Buddhist iconography, part of the broader religious landscape of Southeast Asia. It wasn't until 2007 when Cambodian archaeologist Chanthol Ren examined Granier's photographs that someone noticed the patterns. Rows of small carved circles arranged in geometric configurations, linked by thin grooves, forming shapes that Ren recognized as constellations, visible from the tropical latitudes of mainland Southeast Asia. Wren organized an expedition to the caves in 2008, and what his team documented over the next 2 months rewrote the prehistory of the region. The panels weren't Hindu, they weren't Buddhist. They predated those religions in Southeast Asia by centuries. Radiocarbon dating of organic material in the cave sediments, combined with stylistic analysis of the carving techniques, placed the panels firmly in the late Bronze Age or early Iron Age, a period when the region was inhabited by small-scale agricultural societies that cultivated rice in the river floodplains and hunted in the surrounding forests. These were not the builders of temples or palaces. They left behind pottery, stone tools, and traces of wooden structures that have long since rotted away. But they also left behind these star maps, carved into stone with a level of astronomical sophistication that has no parallel anywhere else in Southeast Asia for that time period. The largest panel, located at the back of the main cave chamber, spans nearly 6 meters across and depicts a hemisphere of the night sky centered on the celestial equator. You can clearly identify the zodiacal constellations, Scorpius, Sagittarius, Capricornus, as well as several that don't correspond to modern Western star lore, but that make sense from a Southeast Asian perspective. One grouping, which Wren has tentatively labeled the water buffalo, corresponds to what we call Aquila and parts of Ophiuchus, and appears to be positioned at the exact point where it would have crossed the meridian at midnight during the monsoon season, when the rains began in earnest and the rice planting cycle commenced. This, more than anything, suggests the panels were agricultural calendars, tools for predicting the timing of the seasonal rains that were, and still are, the lifeblood of Southeast Asian agriculture. But here's where the story gets strange. Several panels depict not just stars, but moving objects, lines carved across the sky field, sometimes connecting one constellation to another, sometimes terminating in small circles that are larger and deeper than the standard star markers. Dr. Sunita Chowdhury of the University of Mumbai, who joined Wren's team in 2010, believes these lines represent comets or meteors, transient phenomena that would have been visible for only a short time before vanishing. One panel shows a large circle with radiating grooves, a textbook depiction of a comet with a tail, positioned in the constellation we call Taurus, close to the Pleiades. Using historical astronomy databases, Chowdhury was able to identify a candidate, a bright comet observed by Chinese astronomers in 532 BCE that passed through that region of the sky and was visible for several weeks. If this identification is correct, it means the Kade Rith carvers were recording one-time celestial events, not just recurring patterns. That's a fundamentally different kind of astronomical record, one that suggests they believed these events were significant, perhaps as omens, perhaps as messages from the divine. Local tradition, as recorded by French colonial ethnographers in the early 20th century, holds that the caves were inhabited by the Nakta, spirits or demigods associated with specific places in the landscape, and that the carvings were made not by human hands, but by the Nakta themselves, as a way of communicating with the mortal world. The stories describe the Nakta as beings of great height and luminous appearance, who could walk between the worlds and who knew the secret patterns that governed the rains, the rivers, and the turning of the seasons. When the people needed guidance, when drought threatened, when the rains came too late or too early, they would climb to the caves and read the messages carved in the stone. Chanthol Wren is careful to frame these stories as folklore, cultural memory that may or may not contain kernels of historical truth. But he also points out that similar traditions exist throughout mainland Southeast Asia, from Myanmar to Vietnam, all describing pre-Buddhist cultures with advanced astronomical knowledge and all associating that knowledge with beings who were not quite human, not quite God. What if, Wren asks, these stories preserve a memory of actual people, Perhaps a specialist class of astronomer priests, perhaps migrants from another culture, who possessed knowledge that seemed supernatural to their contemporaries and who passed that knowledge down through oral tradition until it became myth. It's speculative, but it's not absurd. We know that ideas, technologies, and even people moved great distances in the ancient world. The Bronze Age collapse around 1200 BCE triggered massive population movements across Eurasia. It's entirely possible that groups with specialized knowledge, including astronomical knowledge, ended up in Southeast Asia, far from their points of origin, and that their presence left echoes in both the material record and the oral traditions of the region. Imagine climbing up to those caves at dawn, the jungle below still shrouded in mist, the limestone cool and damp under your hands. You pull yourself over the lip of the cave entrance and see, stretched across the walls in the dim light filtering from outside, a vision of the sky as someone saw it 28 centuries ago. You trace the carved lines with your finger, following the path of a comet that blazed across the heavens for a few brief weeks and then disappeared forever, but that someone thought important enough to preserve in stone. You realize that you're reading a message from the past, a message that says, "We were here, we saw this, and we wanted you to know." And the question that echoes in the stillness of the cave is, what else did they see? And what else have we forgotten? We still don't know. Now we turn to the frozen north, to the rugged coastline of what is now Arctic Norway, where the land meets the Barents Sea in a tumble of granite cliffs and boulder-strewn beaches. This is Finnmark, the northernmost county of Norway, a place of long winters and brief, brilliant summers, where the sun doesn't set for weeks on end and the aurora borealis dances across the sky like green fire. And scattered along a 30-kilometer stretch of coastline between the towns of Alta and Hammerfest are the Jotun Reef Stones, a series of 19 large boulders, each covered with deeply incised grooves and circular depressions that recent analysis has shown to be star charts, accurate maps of the northern circumpolar sky as it appeared during the late Neolithic period, roughly 2800 to 2200 BCE, when the climate was warmer and maritime cultures thrived along the Norwegian coast. The stones were first brought to the attention of archaeologists in 1972 by a local fisherman named Knut Johansen, who noticed that the carvings on several boulders near his favorite fishing spot resembled the constellation patterns he used for navigation when fog obscured the coastline. Johansen mentioned this to a school teacher in Alta, who contacted the University of Tromsø, and a preliminary survey was conducted the following summer. But it wasn't until 2001, when Norwegian archaeologist Dr. Ingrid Halvorsen secured funding for a comprehensive study, that the true nature of the stones became clear. Halvorsen and her team spent 3 field seasons documenting the carvings using photogrammetry, creating detailed 3D models of each stone, and comparing the patterns to historical star charts. What they found was remarkable. The Jotun Reef stones depicted not just random stars, but specific asterisms, recognizable groupings, that were particularly useful for maritime navigation in the high Arctic: Ursa Major, Ursa Minor, Cassiopeia, and Draco, all of which circle the North Star and are visible year-round from latitudes above 60 degrees north. Several stones showed the relative positions of these constellations at different times of the night and year, suggesting that the carvers understood the concept of the celestial sphere and the apparent rotation of the stars around Polaris. One stone, designated JR7, displays a pattern that Halvorsen believes represents a time-lapse view of Ursa Major over the course of a single night, with multiple carvings showing the constellation at different points in its rotation around the pole. If this interpretation is correct, it's a stunning demonstration of observational skill and abstract thinking, the ability to mentally track a moving pattern and represent it in static form. Who carved these stones? The prevailing theory links them to the Kamsa culture, a maritime people who occupied the northern Norwegian coast during the Neolithic. The Kamsa were hunter-gatherers who exploited marine resources, seals, fish, seabirds, and who traveled long distances by boat along the coast and into the fjords. They left behind stone tools, fish hooks, and occasional rock art depicting hunting scenes and boats. But the Jotun Reef stones are different from typical Kamsa rock art. They're more abstract, more technical, and they show a level of astronomical knowledge that seems out of proportion with what we know about Kamsa society. Dr. Mikkel Strand, an astronomer at the University of Oslo who collaborated with Halvorsson's team, has proposed that the stones served as teaching tools, a way for experienced navigators to pass their knowledge on to younger members of the community. In the high Arctic, where the sun is either perpetually present or perpetually absent for much of the year, traditional markers of time, dawn, noon, dusk, become meaningless. The stars, however, are reliable. A navigator who could read the stars, who could tell time and direction by the position of Ursa Major or the angle of Cassiopeia, would have had an enormous advantage in the harsh Arctic environment. The stones, Strand suggests, were textbooks carved in rock, permanent references that could be consulted generation after generation. But there's an alternative explanation, one that has gained traction in recent years as researchers have re-examined the context in which the stones were found. Several of the Jotun Reef boulders are positioned on small islands or promontories that are cut off from the mainland at high tide. They're not conveniently located for casual reference. You have to deliberately seek them out, time your visit to the tides, and sometimes make a dangerous crossing over slippery rocks and kelp. This suggests the stones were more than practical tools. They were ritual objects, places of significance, perhaps associated with initiation rites or seasonal ceremonies. Norwegian ethnographer Lars Bertelsen has collected oral traditions from the Sami people, the indigenous inhabitants of Finnmark, that speak of the Jotnar, giants from the early age of the world, who lived in the far north and who could navigate by the stars even when the sun was hidden. The Jotnar, according to these stories, were skilled sailors and hunters, and they taught humans the secrets of the sea and the sky. When the Jotnar finally departed, some versions say they sailed away to the edge of the world, others that they were driven into the mountains by the arrival of new peoples from the south. They left behind stone markers carved with the star patterns they had used to guide their boats. The Sami call these stones Jotunsteinar, and they regard them with a mixture of reverence and caution, believing that disturbing them brings bad luck at sea. Halvorson is skeptical of direct connections between Bronze Age carvings and Sami folklore, but she acknowledges that the oral traditions preserve something important, a cultural memory of a time when the stars were not just navigational aids but sacred knowledge, passed down through lineages of specialists who were as much priests as they were sailors. There's also the matter of the aurora. Several of the Jotun Reef stones include carvings that don't correspond to any known constellation, wavy lines, parallel grooves, and clusters of small dots arranged in curtain-like patterns. Strand and Halvorson believe these may represent the aurora borealis, the northern lights, which are exceptionally bright and frequent at these latitudes. If true, it would make the Jotun Reef stones one of the oldest known depictions of the aurora. And it would suggest that the carvers saw a connection between the aurora and the stars, perhaps viewing them as related phenomena. Stand on those cold, wind-swept rocks at midnight under a sky lit by the aurora, and you begin to understand why someone might feel compelled to carve what they saw into stone. The lights move like living things, green and red and violet, twisting and folding in ways that seem almost purposeful. The stars wheel overhead, fixed and eternal, and the boundary between earth and sky dissolves into a single shimmering continuum. You hold on to the cold granite to steady yourself, and you feel the grooves under your fingers. Grooves carved by someone who stood where you're standing, who saw what you're seeing, and who wanted to make sure that this knowledge, this beauty, this connection to the cosmos wouldn't be lost when the ice returned and the seas rose, and the old ways were forgotten. And the question that rises in your chest, mingling with the cold air and the sound of the waves, is, what did they understand about the sky that we've forgotten? We still don't know. Let's journey now to the American Southwest, to the high desert plateaus of what is now southern Utah, where red sandstone cliffs glow like fire at sunset, and the air is so dry it seems to pull the moisture from your lungs. This is the Colorado Plateau, a landscape of canyons, mesas, and slot canyons, home to ancestral Puebloan peoples for over 1,000 years, and carved into the walls of a remote box canyon accessible only by a narrow footpath that threads between 200-meter cliffs are the red spiral panels, a collection of 14 large rock art sites dominated by carved and painted spiral petroglyphs that align with solstice and equinox events, but also include what researchers now believe are depictions of stellar phenomena, supernovae, comets, and planetary conjunctions, recorded with extraordinary precision between approximately 1050 and 1150 CE. The panels were first documented in 1984 by archaeoastronomer Dr. Catherine Waverly of the University of Arizona, who was part of a broader survey of Puebloan rock art sites. Waverly had studied the famous Sun Dagger site at Chaco Canyon, where a spiral petroglyph is bisected by a shaft of sunlight at the summer solstice, and she was looking for similar solar markers across the region. What she found at Red Spiral Canyon exceeded her expectations. The central panel, a massive carved spiral nearly 2 meters in diameter, is positioned such that at noon on the winter solstice, a blade of sunlight moves across the spiral from outer edge to center, a journey that takes approximately 14 minutes. But surrounding this central spiral are dozens of smaller spirals, dots, and geometric shapes that don't align with any solar event. They're positioned seemingly at random, scattered across the rock face in a way that frustrated Waverly's initial attempts at interpretation. It wasn't until 2003, when astronomer Dr. James Reynolds of the Lowell Observatory ran the patterns through a computer model comparing them to known celestial events, that the pieces fell into place. One cluster of petroglyphs, a large circle with radiating lines, positioned near a crescent shape, matched the appearance and position of a supernova that exploded in 1054 CE, an event so bright it was visible in daylight for weeks, and was recorded by Chinese, Japanese, and Arab astronomers halfway around the world. The supernova occurred in the constellation Taurus, near the crescent moon, and the red spiral panel depicts exactly that configuration, a starburst near a crescent. It's one of the most compelling examples of ancient astronomical observation in North America, but it's not the only one. Another panel shows a row of 5 small circles arranged in a line, almost certainly a depiction of a planetary conjunction. Reynolds calculated backward through time, looking for alignments of 5 visible planets, Mercury, Venus, Mars, Jupiter, Saturn, that would have been visible from the Colorado Plateau between 1,000 and 1200 CE, and he found a match. On the morning of September 12, 1128 CE, all 5 planets aligned in the pre-dawn sky in a configuration that wouldn't repeat for another 200 years. The red spiral carvers saw it, understood it as significant, and recorded it in stone. Who were they? The ancestral Puebloan people who inhabited this region during the 11th and 12th centuries were sophisticated agricultural societies. They built multi-story stone dwellings, engineered irrigation systems, traded across hundreds of kilometers, and maintained complex ritual and social structures centered on kivas, underground ceremonial chambers. They also had a deep and abiding relationship with the sky. Puebloan cosmology, as we understand it from ethnographic work with modern Pueblo communities, holds that the movements of the sun, moon, and stars are intimately connected to the health and fertility of the earth. The solstices and equinoxes mark critical points in the agricultural calendar, and ceremonial activities are timed to these events. But the red spiral panels suggest something more, that the ancestral Puebloans were tracking not just predictable, cyclical events, but also rare transient phenomena like supernovae and planetary conjunctions. Why? Dr. Waverley's hypothesis, developed over 20 years of research and published in a comprehensive monograph in 2012, is that these events were seen as omens, messages from the sky deities or ancestors, requiring interpretation by ritual specialists. The fact that the supernova petroglyph is located near the central solstice spiral suggests it was incorporated into the broader ceremonial landscape of the site, linked to the seasonal cycles but also understood as an extraordinary event, a rupture in the normal order that required documentation and response. There's also the matter of the canyon itself. Red Spiral Canyon is remote, difficult to access, and lacks permanent water sources. It's not a place you stumble upon by accident, it's a destination, a place you go to with purpose. Archaeological surveys of the canyon floor have uncovered fire pits, pottery sherds, and evidence of periodic habitation, but no permanent structures. The canyon, it seems, was a pilgrimage site, a place where people came for specific reasons at specific times. Perhaps they came during solstices and equinoxes to witness the light and shadow play across the central spiral. Perhaps they came after unusual sky events, supernovae, comets, eclipses, to record what they had seen and to seek guidance from the spirits of the place. And then there are the stories, preserved in the oral traditions of modern Hopi and Zuni peoples, whose ancestors include the builders of the red spiral panels. The stories speak of the star people, beings who came from the sky at the beginning of the world and who taught humans the patterns of the stars, the cycles of the seasons, and the proper way to conduct ceremonies. The star people, according to these traditions, lived among humans for a time, but eventually returned to the sky, leaving behind markers, carved spirals and star symbols, to remind humans of the covenant between earth and sky. When unusual events occurred in the heavens, new stars, moving stars, stars that grew bright and then faded, it was a sign that the star people were watching, that the covenant was still in force. Folklorists tend to interpret these stories as mythologized astronomy, cultural frameworks for understanding celestial phenomena. But there's a deeper truth here. These stories capture the sense of connection and continuity that the sky provided for ancient peoples. The stars weren't distant, abstract objects. They were ancestors, guides, and messengers. To record a supernova or a planetary conjunction wasn't just an act of scientific observation. It was an act of devotion, a way of maintaining the relationship between the human and the cosmic. Climb up to the red spiral panels at dawn, when the canyon is still in shadow and the air is cool and still. Stand before the central spiral and wait for the sun to rise above the canyon rim. When the light finally breaks through, watch as it moves across the rock face, illuminating first the outer coil of the spiral, then slowly tracing inward, a journey from edge to center that mirrors the sun's journey from horizon to zenith. And as you watch, think about the person who carved this spiral 1,000 years ago, who understood the geometry of light and stone so perfectly that they could create this effect with nothing but stone tools and patience. Think about what it must have been like to witness a supernova, to see a new star blaze into existence where no star had been before, and to know that you were seeing something that might never happen again in your lifetime. And ask yourself, if we saw such a thing today, would we carve it into stone? Would we feel the same urgency to preserve it, to mark it as significant, to pass the knowledge on to future generations? We still don't know. Finally, we travel to the southern hemisphere, to the windswept grasslands of what is now Tasmania, the island state off the southern coast of Australia. This is a land of ancient forests, jagged mountain ranges, and a human history stretching back at least 40,000 years, one of the longest continuous occupations on Earth. And carved into a series of flat stone outcrops on a hilltop overlooking the Bass Strait are the Premingana Sky Stones, a collection of over 300 engraved rock surfaces covered with intricate patterns of dots, circles, and connecting lines that researchers now believe represent star charts, lunar calendars, and tidal tables created by the Tasmanian Aboriginal people over a period spanning at least 3,000 years, from approximately 3000 BCE to the time of European contact in the early 19th century. The site was known to the local Tarkiner people long before Europeans arrived, but it wasn't formally studied until the 1990s, when archaeologist Dr. Liam O'Connell of the University of Tasmania began a systematic documentation project. O'Connell was initially interested in the site as an example of Tasmanian Aboriginal rock art, which is relatively rare and poorly understood compared to the mainland Aboriginal traditions. But as he photographed and mapped the engravings, he noticed patterns that didn't fit the typical motifs of tracks, circles, and meandering lines. These were geometric, almost mathematical, rows of evenly spaced dots, concentric circles with precise radii, linear arrangements that seemed to follow specific angular relationships. O'Connell consulted with an astronomer colleague, Benjisti Inchani yet Halman Chalin, Dr. Rachel Murray of the Australian National University, and together they began to decode the stones. What emerged over the next several years of research was astonishing. The Premingana Sky Stones are a comprehensive astronomical record, encoding information about the movements of the moon, the tides, and the positions of key stars and constellations visible from the southern mid-latitudes. One panel, which O'Connell and Murray call the lunar cycle stone, shows 13 groups of dots arranged in a circle, each group containing between 27 and 29 dots, a clear representation of the lunar month, which averages 29.5 days. Around the perimeter of this circle are additional markings that appear to track specific lunar phases: new moon, first quarter, full moon, last quarter. It's a visual lunar calendar, and it's accurate to within a day or two of modern calculations. Another panel, the tidal chart stone, shows a complex arrangement of concentric circles and radiating lines that Murray believes represents the relationship between the moon's position and the height of the tides in Bass Strait. Tasmania has extreme tidal ranges, and understanding the tides would have been critical for the Tarkiner people, who relied heavily on shellfish, seaweed, and fish gathered from the intertidal zone. The tidal chart stone appears to encode the spring and neap tide cycles, as well as the lag time between the moon's phase and the peak tidal effects, what modern oceanographers call the tidal constituent. That this information is encoded in a rock carving made thousands of years ago is nothing short of remarkable. But perhaps the most intriguing discovery is the Southern Cross panel, a large engraving showing a distinctive kite-shaped pattern of dots that perfectly matches the constellation Crux, the Southern Cross, one of the most recognizable features of the southern night sky. Surrounding the cross are additional dot clusters that Murray has identified as Alpha and Beta Centauri, the two bright stars that serve as pointers to the Southern Cross. The positioning is exact, the angular relationship's correct. But here's the twist. The carving shows the Southern Cross not as it appears today, but as it would have appeared approximately 2,500 years ago, before precession shifted its position relative to the celestial pole. This suggests that the carving is at least that old, and that the people who created it were tracking the slow drift of the stars over centuries, a process that requires multi-generational observation and record-keeping. Who were the Tarkiner people, and why did they invest so much effort in astronomical observation? The Tasmanian Aboriginal people were hunter-gatherers who moved seasonally across the landscape, exploiting coastal resources in the summer and retreating to the forested interior in the winter. They had no agriculture, no permanent settlements, and no written language, yet they created astronomical records that rival anything produced by contemporary societies in Europe or Asia. O'Connell's interpretation, developed in collaboration with Tarkiner elders and cultural advisors, is that the sky stones were part of a broader system of knowledge transmission. In a culture without writing, information has to be encoded in other ways, through song, story, and physical markers in the landscape. The sky stones, in this view, are memory devices, places where critical knowledge about the moon, the tides, and the stars is stored in a permanent form that can be passed from generation to generation. The carvings themselves are only part of the system. To fully understand them, you need the oral explanations, the stories, and songs that teach you how to read the stones. Without that context, the carvings are just dots and lines. With it, they're a library. There's also a spiritual dimension that can't be ignored. In Tasmanian Aboriginal cosmology, as in many Indigenous Australian traditions, the sky is not just a physical space but a realm inhabited by ancestral beings. The movements of the stars and the moon are the actions of these beings, and tracking those movements is a way of maintaining connection with the ancestors and ensuring the continuity of the world. Several of the sky stones are located at spots that have clear sight lines to the horizon, allowing observers to track the rising and setting positions of key stars over the course of the year. These observations would have been part of ceremonial activities, rituals timed to celestial events that marked important transitions in the annual cycle. One elder, interviewed by O'Connell in 2004, described the Premingana site as a place where the sky comes down to meet the earth, and said that when you stand on the hilltop at night, surrounded by the carved stones, you can feel the presence of the ancestors, the old ones who first looked up at the stars and decided to remember what they saw. The elder also mentioned a story about the creation of the sky stones, though he was reluctant to share the full version with outsiders. In the story, the carvings were made not by ordinary people, but by the Palawakani, the first people, ancestral beings who shaped the landscape and established the laws that govern the world. The Palawakani could see things that others couldn't, including the patterns of the stars and the hidden connections between sky and earth. They carved the sky stones as a gift, a way of sharing their vision with the generations to come. And on certain nights, when the moon is full and the Southern Cross stands directly overhead, the stones are said to glow with a faint light, as if the ancestors are still watching, still teaching. Stand on that hilltop on a clear winter night, when the Southern Cross is high and the Milky Way arches overhead like a river of light, and the Pacific wind carries the scent of salt and eucalyptus. Look down at the stones under your feet, each one a record of observations made over centuries, each dot a star, each line a connection between earth and sky. Run your hand over the carved surface and feel the texture of deep time, the weight of 3,000 years of knowledge pressed into stone. And ask yourself, what does it mean to remember the stars? What does it mean to look up at the night sky and decide that what you see is important enough to carve into the bedrock, so that your children's children's children will know that you were here, that you looked up, that you understood? We still don't know. So here we are, at the end of this journey through time and stone and starlight. We've walked across deserts and jungles, climbed frozen cliffs and windswept plateaus, descended into caves and stood on ancient hilltops. And everywhere we've gone, we've found the same thing. People looking up at the sky. People who decided that the patterns they saw overhead were important enough to record in stone, to preserve for reasons we can only guess at. These weren't idle doodles or decorative flourishes. They were acts of profound intention, monuments to the human drive to understand, to remember, to connect with something larger than ourselves. The star chart stones, scattered across 6 continents and spanning more than 5 millennia, tell us something fundamental about our species. They tell us that we have always been stargazers, that from the very beginning, we looked up and asked questions. Where did the stars come from? Why do they move the way they do? What happens when a new star appears or an old one fades? And beneath those questions lies a deeper one. What is our place in all of this? The cultures that created these stones were vastly different from one another. They spoke different languages, worshipped different gods, built different societies, but they all shared this one impulse: to look up, to observe, to record. The slab grave herders on the Mongolian steppe, the Parakas, mariners on the Peruvian coast, the unnamed astronomers of the Saharan grasslands, the Khmer ancestors in their jungle caves, the Kamsa navigators of the Arctic, the ancestral Puebloans of the Colorado Plateau, the Tarkanier people of Tasmania, all of them, in their own ways, were doing the same thing. They were trying to read the sky, to decode its messages, to find patterns in the chaos. And when they found those patterns, they didn't keep them to themselves. They carved them into stone, placed them in prominent locations, and invited others to learn, to remember, to continue the tradition. That's what makes the star chart stones so moving. They're not just scientific records, they're gifts across time, messages from the past that say, we saw this, and we think you should know, we understood this, and we want to share it. We were here, and we wanted to leave something behind that would outlast us, that would still be here when our language was forgotten and our cities had crumbled and our names had faded from memory. The stones would remain, and the stars they depicted would remain, and somewhere in that continuity, our lives would have meaning. Of course, many questions remain unanswered. We don't know why the Kavskite astronomers cared about a single planetary conjunction in 1147 BCE. We don't know what the Parakas navigators were tracking with such precision, or whether the Tafadet Circle was a calendar, an observatory, or a temple. We don't know if the Kadai Rith panels were meant to guide the living or the dead, or why the Jotun Reef carvers positioned their stones on isolated tidal islands. We don't know what celestial event prompted the red spiral artists to add a supernova to their sacred canyon, or whether the Premingana sky stones were teaching tools, memory aids, or ceremonial objects. These are the mysteries that keep researchers up at night, the puzzles that refuse to be solved with a single elegant theory. And maybe that's as it should be. Maybe the real lesson of the star chart stones isn't about finding answers. It's about learning to sit with the questions, to appreciate the depth of what we don't know, to honor the people who looked up at the same sky we see and found meaning in patterns we're still struggling to understand. Because for all our technology, for all our satellites and space telescopes and computer models, we're still doing what they did. We're still looking up. We're still asking questions. We're still trying to find our place in the vastness of space and time. The tools have changed, but the impulse hasn't. We're still stargazers, still driven by that ancient human need to understand where we come from and where we're going. The star chart stones remind us that this isn't new. This is what we've always done. This is who we've always been. And they remind us of something else, something harder to articulate, but impossible to ignore when you stand in front of one of these ancient carvings and trace the patterns with your finger. They remind us that knowledge is fragile, that it can be lost, that entire ways of understanding the world can vanish in a single generation if no one bothers to pass them on. The people who carved these stones understood that. They knew that memory is not automatic, that it has to be cultivated, protected, encoded in forms that will survive fire and flood, and the slow erosion of forgetting. They carved their knowledge into stone, not because they thought stone was eternal, nothing is eternal, but because stone was the most enduring medium they had. And they wanted to give future generations the best chance of remembering. Some of that knowledge has been lost anyway. We can see the patterns they carved, but we can't always read them. We don't have the songs that went with the stones, the oral traditions that explained how to interpret the markings, the context that would make sense of what we're seeing. We're like people who found a book written in a language we half understand. We can make out some words, guess at some meanings, but the full message eludes us. And that's a tragedy, but it's also a reminder. It's a reminder to preserve our own knowledge, to pass it on, to make sure that the things we've learned about the stars, about the earth, about ourselves, don't disappear when we're gone. It's a reminder that every generation is a link in a chain stretching back to the first humans who looked up at the night sky and wondered. And it's a reminder that the chain only holds if we each do our part, if we learn and teach and remember and record, so that the next generation can see a little further, understand a little more, ask better questions. The star chart stones are proof that this has been going on for a very long time. They're proof that the people who came before us cared about the same things we care about. They looked up at the stars and felt the same sense of wonder, the same yearning to understand, the same quiet recognition that we're part of something vast and beautiful and mysterious. And they left us these stones, these silent, patient, enigmatic stones, as an invitation to look up, to ask questions, to remember, to care about the things that matter, the things that endure. So the next time you're outside on a clear night, take a moment to look up. Find the North Star or the Southern Cross or the Pleiades. Trace the arc of the Milky Way across the sky. And remember that you're seeing the same stars that someone carved into stone 3,000 years ago, 5,000 years ago, maybe more. You're part of the same story. You're asking the same questions. And somewhere, buried in the earth, or hidden on a remote hillside, or waiting in a cave that no one has entered in centuries, there might be another stone, another set of carvings, another message from the past that we haven't found yet. Keep looking, keep digging, keep asking, because the stones are still out there and stars are still overhead, and the story isn't finished. It's never finished. We still don't know where it's going, but we know it's a story worth telling, worth preserving, worth carving into stone so that it will outlast us. And maybe that's enough. Maybe that's all we can ask for, to be part of the great human conversation that stretches from the first carved stone to the last human who looks up at the stars and wonders, keep digging. Some secrets still lie just beneath your feet, waiting for the right eyes, the right questions, the right moment of recognition. And when you find them, remember, you're not the first to ask these questions. You're not alone in your wonder. You're part of an unbroken lineage of stargazers, stretching back to the beginning and forward to whatever comes next. The stones are waiting. The stars are watching. And the mystery, beautiful and unsolvable, goes on.